In this work, we present visual grounding in augmented reality. To understand visual grounding and how you will be useful in augmented reality, please look at this example. So imagine yourself with having AR devices and is wearing them while you are bouldering in front of a spray wall, which has no preset route. You may want to ask AI, so can you find me a route with large handholds? It's easy to climb. And in visual grounding, the model would answer a question, but also answer a question on the video. So now you may want to in front of the spray wall, you just ask it, and you just give the preset route, nice and simple. But what is that we have the problem that restrain us from having that capability deployed to AR, and we can enjoy it in every bouldering gym right now. So firstly, SAM2, which is a very popular segmentation model on video and support this feature, actually require 80 gigabytes of memory. And it requires 80 gigabytes memory to operate at 100 FPS, which is standard for fluent video experiences. However, in our consumer grade AR devices, we only have 8 gigabytes of memory. So that's 10 times less of a memory through SAM2. And we only have 1.84 TA flops, which is also around 10 times less than 800. And a visual grounding model also includes very strong large language models, and then that's over 1 billion parameters to also deployed to AR devices, which is very, very hard and not very feasible right now. We also have another issue, which is a granularity limitation. So we have different granularity, meaning whole, part, and subpart. So in this work, we only focus on part level, but as you may see from here, that parts is really important in some segment from that. So maybe we'll just one segment, some part of it, and this is a huge issue in visual grounding. So basically, this is an empirical study, which we just want to answer two questions. Firstly, is how SOTA visual language model perform on par level grounding with some standard GPU 800 in this sample. And then is it possible to deploy segmentation module, so only segmentation module of the visual grounding model to AR. Firstly, to verify to answer our question, we designed Momo, which is a very popular visual language model, open source by Allen AI. And then we asked it to point out a part of the object. And then in this example, pointing out bird tail in the image. And then from that point examples over here, we then prompt Sam to segment the whole object. In this example, it's actually really bad because for bird tail, we only want this region, but it's segment the whole region. And that's one of the limitations we will explore later. In our demo or AR devices example, we're trying to convert the SAM only segmentation module to Onyx format, which is an open source format for edge computing. And then we will build things, meaning to create UIs for Unities, and then load that to Centis, which is the running environment of segmentation models on Unity. And then we will quantize that to FP16 so it can run on Quest devices. From our experiments, you could see over here, left was the hours example and right is the ground truth. We have two sets of examples. And from here, you can tell the pointing was really, really accurate, most of them. It was right on point for most of the segmentation, ground truth segmentation maps and the pointing effects. But what was lacking was pointing that specific region actually ground the whole object level rather than specific region. It's same thing over here in the laser. It gives the whole example rather than only subpart, only the part. So that's one of the limitations we found through the most visual grounding model, which is the limitation on segmentation models. And then we also find that from Quad demo, this took about 10 seconds to run. And then we also find it was impossible to convert SAM2 to honest format because SAM2 actually use different frames at different encoders. So this is not impossible to do video segmentation. And that gave us our strongest conclusion from our empirical studies. Firstly, is like most of SAM would default to whole object mask, which is not optimal. We want to solve that. And also, like, it was impossible to deploy SAM2 over Quad. So I think that's a two very promising area for my future research to deploy video models and also to bring that visual grounding model to subpart level.